And he's an expert on technical modeling, data science, and automation projects for Department of Energy. And prior to joining USDOT, Dr. Zhang receives a doctorate degree in the MIT Operations Research Center. And his thesis and his expertise was on developing analytical models for real-time calibration of traffic simulators. Without further ado, Kevin, the floor is yours. Thank you.
Great. Thank you so much, Manshu, for that invitation. I'm very excited to speak. Let me go ahead and share my screen. Okay.
Yeah, great.
Great. So, I'm Kevin Zhang. I'm a statistician at the U.S. Department of Transportation Volpe Center. Today, I'll be talking about some scenario analysis tools that we've developed at the Volpe Center and how they relate to transportation optimization and resilience. So here's a picture of our new building. We moved in a couple of years ago. It's located in Massachusetts at Cambridge, right across the street from MIT. And we operate as part of the federal government, as I'll talk about, but we have a sort of cross-modal role, which is unique within the Department of Transportation. So we sit under the Office of the Assistant Secretary for Research and Technology. This is in the Office of the Secretary of Transportation. And again, speaks to our ability to kind of cross the different agencies, federal highway, federal aviation, rail, transit, etc. And we are kind of sort of like the research center for the Department of Transportation. We take a kind of systems level thinking and apply it across different modes on different types of innovations and emerging and future transportation issues. We are a fee-for-service organization, which is a little unique as well in DOT, in that we are funded on interagency agreements and do work project by project. And we have experts at the center across all different types of technical areas. I'll talk a little bit about my division, energy analysis and sustainability, but we have a lot of economists, safety experts, as well as engineers, planners, people who work on position, navigation, and timing as well. And this is where I've sat since 2020. My division is the Energy Analysis and Sustainability Division, and we're really focused on how to supply energy for the transportation networks that we all use, as well as transport that energy, whether it's traditional fuels, electric vehicles, other types of alternative energy to different parts of the US. We have actually developed a pretty nice data science and AI group within our division. And again, because of just how we're structured, while this is our primary focus, a lot of us work across different other divisions as well. So I'm going to talk kind of generally about two different tools that I am the technical lead for, but this is really focused on kind of understanding how we can think of the transportation networks that we all use as critical infrastructure that needs to be maintained by public sector agencies. So I think probably as everybody's aware, transportation networks are really essential to understanding how people get to where they need to go, as well as getting freight and other types of commodities to people who need them. And infrastructure in the public domain is really kind of where we come in and can offer an understanding of where is infrastructure most critical, most vulnerable, and most in need of action. And this really becomes even more apparent in situations of disruption for natural hazards or other types of, say, like cybersecurity events, where that transportation network is impacted and also becomes more critical as a function of, say, emergency response or evacuation. And this is really aligned with kind of the focus of the federal government now. So a recent executive order that came out really is looking to direct federal agencies to empower users at the state and local level to prioritize resilience and to provide them the types of tools that they need in order to make those decisions in an economically sound way. So that's kind of where us at the Volpe Center have come in and thought about what sorts of gaps can we fill, what sorts of tools can we provide to allow these users to make the decisions that they need to make in funding different infrastructure projects. So our primary focuses here are to create tools that are low cost, ideally free to use, open source and very transparent about how they function, as well as being easy to use for agencies and of different varying technical abilities, leveraging either data that they already have available and making that kind of plug and play with tools that we have, or allowing them to use public data sources to supplement any data gaps they might have. And we really are focused on creating actionable tools. So in addition to just providing an analysis, we want to empower them to be able to make decisions based on that analysis. So the two tools that I'm going to talk about today, both of which are developed within our division, are the Freight and Fuel Transportation Optimization Tool. This was originally developed for the FAA, but has been used across many other users. And the Resilience and Disaster Recovery Tool Suite, which was developed in support of the Office of the Secretary of Transportation, their research, development, and technology team. Both of these tools are open source. We have GitHub repositories for both of them, and they're available for download. So starting with FTOT, this is a scenario planning freight optimization tool. So freight and fuel supply chains are critical to provide essential goods across the US, and transportation across all different types of modes is a critical element to making these supply chains operate. So what FTOT is trying to answer is what is the best transportation solution to maximize your delivery of goods while minimizing cost? And how does that solution change if you have different inputs? For instance, if your network changes, you have infrastructure that comes online, or you have a disruption, how would that impact your supply chain? So we are looking at at its core, an optimization problem on the multimodal network. So FTOT runs on ArcGIS, which you do unfortunately need a license for, but it's the only kind of dependency of FTOT that requires kind of a paid license. It's built in Python with also kind of an optimization core run through Pulp. And what it's looking to do is to maximize delivery of your finished products to their destinations while minimizing this kind of generalized cost. We've used this for several different sponsors since it was first developed for the FAA. Originally, it was really focused on how do you get sustainable aviation fuels to the nation's airports. But since then, we've made the tool commodity agnostic, supply chain agnostic to whatever the user wants to kind of input in terms of data. We've worked with Department of Energy, the Pipeline Hazardous Materials Safety Administration, USDA, Oregon State University as well. And we have users across government, academia, and the private sector. So as a scenario testing tool, what it's looking to do is analyze how changes and impacts, then create different sort of optimal routing solutions. And in this inset, you can see an example of that. For an analysis that we did in Louisiana on their sugar supply chain, we considered what would happen if a rail link that had fallen into disuse was revitalized. How would that change the modes used for this particular supply chain? And as you can see, part of the shift in mode went over to rail with that revitalization. So in terms of the cost and our objective function, it's primarily transportation cost. We're looking at a per ton mile for most of our modes, but also origin destination pipeline tariffs for the pipeline network. But we also incorporate things like transloading costs. So that's the cost of moving from one mode to the other. Different impedances and weight parameters that we use to incentivize more realistic routing. For instance, routing on highways as opposed to local roads for longer movements. And then I think, something that's very unique to FTOD is we look at different facility characteristics within your supply chain. So along the way, when you're routing, your commodity may change form. You may turn corn stover into sustainable aviation fuel at a facility, for instance. And FTOC can also help you find locations to build certain facilities like refineries in order to minimize transportation costs. Part of our code base includes a multimodal network that we've developed for the US based on several different public data sources. We have the road network, a rail network, inland and coastal waterways, as well as crude oil and petroleum product pipelines. And we have compiled a series of intermodal facilities as well to move from mode to mode. But something that we've done recently is, in order to make it even more customizable to the user, allow the user to bring their own network as long as it meets our schema to the tool. Some examples of where we've done this is some fuel supply chain work that we've done in Colombia with the support of the Federal Aviation Administration, as well as some more detailed road network analysis that we've done for Oregon State University and the Pacific Northwest, because they were very interested in kind of understanding more of that first mile, last mile component of getting to different fields within the Pacific Northwest where they're growing hemp. So as long as kind of it follows the schema, we've made it compatible with running an FDOT optimization on top of it. And some of the kind of support tools that we have are trying to help users, say, take OpenStreetMap data and turn it into an FDOT node. For optimization, we rely on public solvers. So really, we have two that are configurable by the user, the cut and branch solver by CoinOR, as well as Highs. And both of these take information from the multimodal network, and then the user supply chain data turns it into an optimization problem, and then plugs it into the solver. And then finally, it translates all of that back into kind of geospatial information for the outputs that FTOP produces. Just because I felt like I should put some math in here, I went ahead and just put in the optimization problem. It is in our documentation as well. It's not super different from just like kind of a multi-commodity flow problem. We do have some kind of special components around like facility build cost if you're trying to site new facilities, as well as these sorts of processor conversion of flow constraints where one commodity coming in may not be, say, like conserving mass necessarily, but is being converted into another commodity coming out. The other ones I think are kind of your standard constraints that you see. So that's kind of like what you'd consider a base FTOT run is you would the user would input their data, their facilities and conversion processes, and then they would run FTOT and get an optimal routing solution. But for a lot of our sponsors and a lot of our collaborators, what we're doing is we're running multiple different FTOT scenarios together to really understand the impact that a change in your inputs would lead to in terms of your outputs, the actual like mode choice and routing that you take. And then we package all this up for the user in kind of the final step of the code and output a lot of static maps using ArcGIS. We create an interactive Tableau dashboard, which is an easy way for users to then kind of slice and dice the data as they want to. And we also have a lot of flat files if you want to kind of do your own data analysis on it. Our Tableau dashboard also allows you to take different scenario runs that you've done before and kind of aggregate them together and compare them side by side. And then finally, we have a set of kind of standalone supply chain resilience tools that we've developed that sit on top of FTOT. They look at resilience in a couple of different ways. One is sort of your standard link knockout approach, where once you have an optimal solution, you can rank the different links in your network routing solution by some sort of measure of importance. So we use betweenness centrality as kind of the default, where the links that are most critical to your supply chain are then removed one by one, and you can see the rerouting impact of doing that. We can generate charts like the one on the right, bottom right here, where as you disrupt more and more links, you can see your objective function increase. And at a certain point, you might see a big jump, for instance, and that's kind of how we consider sort of like the set of links that would be really significant to disrupt. There's another tool that is more focused on actual kind of infrastructure fragility curves. This was developed in collaboration with some researchers at Washington State University. And this overlays an FTAW optimal solution on hazards data, which is provided for different types of natural hazards, and understanding how the impacts of those hazards on infrastructure will disrupt your FTAW solution. Just to give a sense of kind of the ongoing work that we're doing now with different collaborators, as well as some work that's just wrapped up. A lot of it, as you'll see, is focused on fuels. I think, we are still very much a fuel supply chain tool, though we have branched out from there. We're looking at other agricultural supply chains, a lot of this work for Federal Aviation Administration. One kind of interesting version of the tool that we've recently developed for Pipeline Hazardous Material Safety Administration is taking, instead of a cost-based optimization approach, looking at risk of hazmat release events and the potential consequences to local populations. But that is currently still a beta tool there. So I'm going to talk a bit about RDR, and then I can take questions. So the Resilience and Disaster Recovery Tool Suite is a sort of different perspective on transportation network resilience. So instead of focusing in on one particular supply chain, it's looking at all transportation network users and the economic impacts of different mitigation projects on their ability to travel across your network. So transportation networks are under constant threat from hazard-related disruptions. There's a lot of uncertainty as well around what sorts of disruptions you may encounter in the future. So coming up with resilience investments on infrastructure is a way that you can reduce these future costs while for disruption to network performance. And what public agencies really need to make decisions about are which of these infrastructure investments in their planning process are the ones that will provide the greatest return on investment if they don't know what the future really holds in terms of disruption events. And RDR is really trying to help agencies understand that problem. And then RDR can also help you understand how are those benefits that you accrue from a mitigation project distributed across different users in your transportation network. So when we talk about return on investment and sort of a benefit cost framework, particularly as it serves DOT's kind of grant needs and justifications, we're looking at balancing an upfront cost of the project against the potential benefits that it will accrue if a hazard event occurs. So this benefit in the future is measured in two different ways. One is on network performance. So during the hazard event itself, if trips are disrupted, if they're rerouted and take longer, then that costs more money, and hopefully a resilience investment would lower some of those disruptive impacts, and kind of that would be the benefit when compared to not doing the resilience investment. And then also a project will help decrease the repair time and repair cost of that impact to that asset. So if you combine all of these things together, you get a net benefit for that particular project compared to sort of a no action baseline when this particular hazard occurs. The real challenge, though, is we don't really know what hazards and what severities are we going to see in the future. There's a lot of uncertainty and different probabilities around that. So when you're trying to come up with a plan, you sort of need to weigh all possible futures kind of together when you're creating your benefit cost analysis. And you also have probably hundreds of projects that you're looking at any one time to evaluate against each other. And when you put all those things together, this can be thousands of scenarios to test. Um, Traditionally, public agencies use travel demand models in order to understand impacts and to on network performance. But these are pretty heavy-duty tools or programs that can take, somewhere like a day to run one scenario. So when you're looking at thousands of scenarios, you don't really have the time to do so. So RDR is using a meta modeling approach to try and reduce that computational time and really allow a user to weigh different scenarios in your scenario space together. So it is a tool suite in that we have several different tools that the user can kind of employ depending on their needs. The main tool is this ROI analysis tool, which produces that project return on investment and ranking. But we also have an exposure analysis tool, which helps you overlay like a hazard event against your network, and the benefits analysis tool, which is the one that disaggregates your benefits across different users of your transportation network. Again, this is a publicly available tool, and it really is looking at screening level network performance here. So this is something that we really envision public agencies using at the beginning of their planning process. They have a lot of other sort of economic justifications and model runs that they do. If they want to layer resilience into that planning, RDR is really kind of best suited at that stage. It is hazard agnostic, so as long as you can translate any disruption events into link level impacts on capacity, it should work with RDR, and it looks at both passenger and freight trips. We do have a transit module as well, so you can kind of enable that and have in your network both the road network as well as any fixed guideway transit. And its ultimate goal is to really provide a USDOT aligned benefit cost analysis to understand how your resilience project justification could occur for any sort of USDOT grant making process. So I think I kind of covered this already in the previous slide, but there's three components to this tool. So if a user has raster level hazard data and they have a network in terms of line features, they can use the exposure analysis tool to do an overlay and understand the geospatially explicit kind of impact of the hazard on different links in their network. And then they can take those inputs and then bring it into the ROI analysis tool, where the meta modeling approach is used to both sample and then extend out to all the scenarios in your scenario space and produce a Tableau dashboard of a regret and benefit cost analysis ranking. And then finally, once they've kind of run the ROI analysis, they can dig into any particular project, any particular hazard, and understand then how that project, the benefits of that project are impacting the different populations. We've enabled a couple of different sort of like economic approaches, depending on what the user has in terms of data. The traditional one is this benefit cost analysis. So if you do know things like your hazard probabilities and you do have things like project costs, you can run sort of that traditional weighing of benefits and costs. But if you don't have hazard probabilities and your uncertain futures are more equally considered, you can do what's called a regret analysis. So this is looking across all your potential futures any project, what is the regret you might experience from implementing this project instead of the best case project in any scenario. And then if you don't have project costs, you can do what's called a break-even analysis. And that'll just give you kind of a quantification of the potential benefits that a project would accrue. And that can be something you can then consider against, what's the maximum cost of that project that you could afford and still get a positive net benefit from it. Like I've taught, we've really tried to develop very user-friendly outputs. So we have a Tableau dashboard again that breaks down the analysis in different ways. You can look at that higher level benefit cost or regret ranking, and you can drill down into a particular asset in your network, like a bridge that you might be considering different projects on, and compare those against each other, or sort of just explore across all the different metrics that we output and see if there's any thing that you want to dive into further. So the methodology kind of behind RDR is based on a framework for robust decision making that was developed by the RAND Corporation. It's been implemented in a couple of other US DOT projects, primarily TMIP EMAT, which is a kind of scenario planning tool as well, but less focused on resilience and more just kind of on your general urban populations. And what it does is it starts with some sampling of this lightweight core traffic assignment model called Equilibra, which was developed, I think, by researchers at Argonne National Labs. And through a couple of samples of Equilibra runs, it uses a regression approach to build that out across your scenario space for a particular single day disruption event. Then RDR will take those single day disruptions and kind of concatenate those against each other to create the full recovery process. And then finally scale all of that up to your analysis period, which for agencies is usually, something like a couple of decades that they're looking at infrastructure projects for. We use a Latin hypercube sampling approach to pick the actual scenarios that we want to run through Equilibra. There's an R package called random LHS that's really helpful there. And then the regression, we allow the user to kind of, depending on their scenario, pick among a couple of different versions. We have a Gaussian multi-target regression that is our default, but we also have things that implement like a mixed effects regression model, or if you just want kind of your standard regression, you can do that as well. And we are really grateful for this tool, which is a lot newer than FTOT is. It's only been publicly released in the last year or so to some of our pilot partners. So we've worked with specific planning agencies at Hampton Roads, Hillsborough County in Florida, and the Houston-Galveston region to beta test this before it came out officially to the public. Now that it's been publicly available, we have a couple of different user types. I would say primarily at this point, we have a lot of transportation consultants who will take this and use this with state DOTs and MPOs, but we also have a couple of academic users as well. And to highlight Hampton Roads in particular, I think, this is a partnership that we've been really proud of. We have actually become part of their official project evaluation process. So, they have their 5-year plans where they do kind of a fiscally constrained project prioritization, and they've incorporated RDR outputs into that planning process every 5 years. So we actually just wrapped up work for their 2050 plan. So I think, just in summary, what we've really tried to do here is identify gaps where network analysis tools could help. And in particular, create tools where the user input side as well as the output side are kind of readily available for non-technical folks, though a lot of the actual core model in the background, we have a lot of documentation and videos to help them install the tools and also to run them. but we also help with technical assistance and are just kind of widely available to our users to help them kind of implement uses of these tools and whatever problems that they're trying to solve. Both of these tools have slightly different focuses, but they really are looking at trying to justify and understand how different impacts of disruptions on your supply chain or your network will lead to things that you need to anticipate and plan for. Um, for FTOT, I think, we have these two modules that test resilience. Those are kind of a way to then think about, planning for your supply chain and understanding, like, is there a particular sort of uncertainty that you want to look at, while the RDR tool is really kind of focused on uncertainty as its bread and butter. Both of these tools, again, are publicly available, and we are still every once in a while releasing new versions of them. So we have active kind of user bases that we engage with, and we have user groups that we meet with as well to just understand the problems that they're looking at and try and develop new solutions for them. But yeah, I think with that, I think I wrapped up a little early, but I want to thank you for your time and for letting me come speak at Berkeley. I'm very happy to answer questions, whether it's about Volpe itself or the two tools that I help support.
Thank you, Kevin. This is wonderful. And I think I have a few questions, but I will let the audience ask first. James?
Oh,
No?
I will go later.
Awesome.
Yeah, I have a ton of questions, but I'll defer to students. Okay, I'll jump in. Yeah, I have like 4 questions, so maybe I'll ask 2, pause, and then maybe I can ask the other 2 later. So, yeah, Kevin, thanks again. Maybe I'll start with FTOD. So first question is, the RPE program intermodal. I'm just curious, can you talk about how that's overlapping or complementary to FTOT? Because I followed a little bit what's been going on in that program. So I'd be really curious to get your perspective on that.
Yeah, no, I think that's a great question. So FTOT, you know, was developed before sort of those ARPA-E intermodal projects were awarded. I think there are slightly different flavors for what they're looking at. I'm only really aware of a couple of them as I've also just kind of been following them tangentially, but they are sort of all focused on this multimodal aspect, I think. For FTOT, I think it's a little higher level kind of planning is the focus. A lot of those are more operational as I understand it. And this is really taking kind of that first pass of like, what is the high level impact of building a refinery in one place or another place, for instance, or what is kind of the impact of changes in your supply chain, where the other ones I think are more kind of focused on sort of like comprehensive system level understanding of um, different is it like energy supply chains?
I think it's focused on freight writ large.
Okay. Yeah, I mean, there's a lot of commonalities. We share a lot of common data sources, I think. But I would say the kind of scales at which the kind of analyses are done are pretty different.
Okay. And then my other question related to FTOT is, there's a question where I truly don't know the answer. I'm not an expert, so it's not one of those where I'm asking a question and I already know the answer. But there was an MIT Mobility Forum seminar, I think a couple of years ago, where someone came in and explained, in freight, there's actually a market of shipping operators and then shipping customers, which makes the systems level analysis, like the network flow as you showed it, and the way I would like to think about it, I guess way more complicated. When you consider that, the actual decisions of what gets shipped and how, and ultimately goes through these markets. I'm wondering if you could talk about that and yeah, help me understand maybe just a little bit more how those how those markets work, and is there some way that could be incorporated with that time?
Yeah, also good question. I think it's the easy answer is like it's out of scope for FTOT. We aren't really focused on that sort of logistics side of things, but there are often a lot of questions about that. I think there's also questions about sort of like just-in-time delivery, for instance, that we don't really consider in FTOT, which is not looking so much at time to deliver goods to their end destinations, but more focused on sort of that higher level planning cost. There are other models that I am aware of. I think a lot of, privately built ones, but things like national freight models that consider things like backhauls and like, if you take a truck and you're trying to match it to someone who needs to ship something, there's some sort of like market matching uh, kind of like bidding that happens and trying to model that. Um, it's not something I work on personally, but I think there are folks at Federal Highway Administration who are considering more kind of detailed model for for that type of thing. I think otherwise, there's a lot that we kind of scope out of FTOT because to really get into the details of those models would involve a lot more data. And also another sort of primary goal that we have in terms of FTOT is it's not going to be a data querying tool in and of itself. The user is meant to supply their own data, their own supply chain structure to the tool, and then FTOT will take that and run it. I think we hesitate to take on the burden of sort of keeping that data up to date and understanding like how that's changing over time. With our network, it's already um, a bit of a sort of maintenance process where every time there's a new version of like the North American Rail Network that comes out, we go ahead and we update our network. Intermodal facilities is a constant sort of um, big push to really kind of get a publicly available and also well maintained data set for that. So um, I think when it comes to more specifics about how freight moves across the US, we sort of rely on the user to provide that, right? So we are trying to kind of customize and allow adaptability of FTOT to start to incorporate some of that modeling into it. Like you can change your costs to sort of mimic the issues of, say, like finding a right shipping company to move your good from one place to another. We have this customization called access cost, where if there's particular facilities that are more difficult to reach, you can add an additional cost to that facility as opposed to other facilities that provide the same materials. So we do allow the user to kind of simulate that with an FTOT, but we don't go nearly into as much of the logistics details of like finding, a third party logistics shipper or something like that.
Okay, thank you. So I have a few questions. So I think the first question is actually related to what you have just said about what data that you guys keep and update and what kind of scenarios are the input from the users. So I find this first part of like building this entire network that you showed on the entire United States multimodal like really fascinating. Like, can you like get into a bit detail about like, for example, what are the key data sets that you used? And like, how do you make sure that the network that you modeled actually reflects what's the actual cost? Because I think a lot of students working on these similar problems, they face this challenge of
Yeah.
they find the data, but they want to calibrate the network and they run into a lot of difficulties.
Yeah. So this kind of summarizes, at least for the default multimodal network that we use, where our sources are. A lot of them are US Department of Transportation sources, but for like waterways, really the kind of definitive network there is an Army Corps data set. What we do is we have this kind of stitching together an intermodal network script that we've written in ArcPy to bring all these data sources together. We do some of our own filtering as well. So, there's some details about like for waterways, a barge has a draft of like 9 feet. So we filter out any waterways that are below that draft as not navigable for our freight kind of modeling. It's definitely a tricky process. I think developing the scripts to do so falls with our GIS team more so than it does with me. But I would say that if you're looking at something at the national scale, these really are kind of for DOT the places to go in terms of data sources. We do see a lot of interest in more regional analyses or international analyses, and that's where we kind of have fallen to OpenStreetMap as a good source. But there's pros and cons to that. I think it's really great that it's maintained and as detailed as it is. And the types of attributes that we're looking for are not particularly complicated. It's things like, is this a one-way link? Is it a two-way link? What's kind of your functional class if it's a road network, or that's how we use impedances to kind of prioritize different routes. But we can translate a lot of those from things that people have in OpenStreetMap, for example. And then the other big piece of it is just like it needs to be routable. So considering things like grade separation, understanding that like if a network has two roads that cross each other, but one's a bridge and one's like an underpass underneath that, you shouldn't be able to route from one to the other. So you just want to make sure that when you're looking for a data source, it preserves that kind of information.
So in here, when the first one that you said is a freight analysis framework, so I assume like this doesn't include all types of streets, right? So you have to filter out and only keep like the main highways or depending on the goal of the analysis.
Yep. Yeah, that's right. So the Freight Analysis Framework Network is developed by the Bureau of Transportation Statistics. They use it for routing as well, and it only includes really functional classes 1 through 4 or 5. So it's not getting to that local level. Yeah.
Okay, yeah. I have a second question, which is about the second half of the talk. So when you assess this resilience, especially if you account for the recovery process of a disastrous event, like oftentimes you wouldn't have the data for that particular scenario that you look into, right?
Right.
So how do you make sure that your analysis is truthful? I think that's also a question that's like people face a lot of doing when trying to do research on this topic. So it would be good to hear your insights.
Yeah, it's it's definitely a great question. And when we have worked with our pilot partners, even then, when they've done vulnerability assessments and tried to understand kind of the hazards that their particular region faces, they often don't know kind of what to set for those. So we do have a couple of defaults that are provided within the tool, which people do end up using quite a lot. And we have sort of references in our documentation to where those defaults come from. That's also kind of how we get a lot of our repair cost and repair time information, like what is the average time for repair for a bridge versus a highway in a local setting or a rural setting or an urban setting. I think getting to the realism part of it, particularly when it comes to the BCA and the justification there, because we're focused primarily on that sort of first pass scoping and just like narrowing down of projects from a list of say like hundreds to maybe like 50 that they're going to consider in a fiscally constrained analysis, more so than the actual value itself is like the ordinal ranking of them, like that regret ranking that I'm talking about. So really, they're trying to get that first pass sort of gut check of the resilience component of it. I think you could do certain things like run an RDR a couple of times with sensitivity analysis. And with a lot of the hazard uncertainties in particular, we actually do expand the scenario space to consider, is this hazard going to last 2 days? Is it going to last 4 days, for instance, or things like that? And we test across a range of different scenarios to sort of balance out the impact of, say, like one particular type of hazard on your BCA.
I see. Yeah, that makes sense. So any other question from the audience?
Yeah, I knew the first part would be interesting to me, but the RDR part is much more intellectually interesting to me. And following on Monsieur's question, yeah, if you were to ask me what is the most important, challenging intellectual question, the RDR question, I think would be number one, or at least in the top three for me. So in particular, you know, we're keenly interested in rare extreme events, right? Where the probabilities of the hazard are exceedingly small, maybe increasing a little bit with climate weirding and whatnot. And then the costs and whatnot that Muncie was just referencing are uncertain. And so my question is, how do you think about building this tool? Because I think fundamental, like if it's framed as a return on investment, then the thing is, you have a probability assigned all these hazards and they're exceedingly small and incredibly uncertain, because we might be talking about once in a 20-year, 50-year, 100-year event. And a return on investment, what does that mean? Because we don't live in a multiverse where we can like simulate forward 1,000 times different 1,000 scenarios and see like in an expected sense, what is the best decision that provides return on investment. There's going to be 99 cases where there's a bad return on investment, and then one case where there's huge return on investment.
Mm-hmm.
So how do you think about that? Like Texas, ERCOT made the bet that we are not going to harden. We are not going to harden any of our energy infrastructure from cold climate, because we're going to try to keep energy costs super low, right? And then we saw what happened. So,
right.
So it's almost like philosophical. So how do you go? And then what do your pilot partners? How do they think about it? Sorry for the long ramble.
No, I don't. I'll try to answer as best as I can. I do think it's a little bit of a difficult problem to come to a satisfactory solution on, because then ultimately your infrastructure investment, your choice is either going to pay off or it's not. And you don't really know, because you haven't seen the other futures where maybe a differently directional hazard actually would have made it a better, bang for its buck. I think, a a lot of it is, again, passing the buck is like the user has to define their scenario space well in order for the outputs of the tool to sort of be usable, right? If you don't really consider from the start the full range of hazards that you might face, then your benefit cost analysis that you get from the tool is not going to be encompassing all the potential benefits that you get, or maybe like overemphasizing certain types of hazards when others are actually things that you should be considering in your scenario space. So a lot of what we try to do with our users is to make sure they're thinking about those questions. And, if Hampton Roads, for instance, their main thing is sea level rise and flooding events that might occur. They have 100-year floods. They have 10-year floods, which are a lot more frequently, likely to happen. But they have already done outside of the tool a lot of vulnerability assessments and say like climate modeling, or have gotten from NOAA climate models of like what are the regional impacts that they're going to see. And that's what they need to kind of like research and do before they bring it into the tool. Um, so a lot of it is mostly, I guess, just kind of like education and conversation around making sure that they understand sort of like what they bring to the tool is kind of what they're going to get out of it. I don't know if that really kind of answers your question, but I think that is maybe not quite as emphasized because you see the data, you see the tool, and you're like, oh, I have some data and I'm just going to put it in the tool. But really, that first step of like understanding how you define your scenario space is really important.
Yeah, thank you. That helps. And actually, I think on slide 35, you described a scenario in which you don't know the probabilities of the hazards, right? And if I understand, you're kind of transposing it in the sense of instead of saying I know the probabilities and I find the best investment decision. If I understand correctly, what you're saying here is you're saying let's consider an investment decision and then the array of hazards that could occur, what is the best decision I could have made, and then you could rank from there. So I guess that's part, it's like a different way to look at it, right?
Yeah. Yeah, exactly. You can
That's
kind of
nice.
maybe think of it a little bit as sort of a mini max. It's mini max, but where the probabilities of events are all kind of equally likely is sort of how I've been thinking about the regret analysis.
Got it. Got it. Yeah.
Any other questions?
I have one non-technical question along the lines of what Scott was talking about before. I'm curious if you've had many conversations or talked with potential private sector users of either of the two. So freight and logistics, but then you could see insurance as a possibility. Look, so far we've been talking about academics, government, and private sector that's working directly for the government. I was curious if there are other potential users that you're thinking about, especially considering the current political climate.
I think the short answer is a lot of those potential users have more expensive, probably better tools available to them. So we don't see a lot of them coming to us.
Yeah.
I think where we really have our kind of unique point is that for the public good, kind of empowering folks who maybe don't have access to those sorts of tools to still be able to do some sort of analysis in this field. I don't think we're definitely not um, ruling out users of that type. We just haven't really had a lot of experience with people in the private sector.
And I guess this is the follow-up, but especially for F-top, and I'm sorry if you covered this already, in the scenarios that you have, do you have any reasonable facsimile of freight data, especially nationwide freight data that others can use? Because as we were talking about, that's often one of the biggest hurdles, not just for students, but for academics in general, like relatively easy for me to get passenger data, traveler data, a heck of a lot harder to get any sort of freight data because that's almost always private.
Yeah, I have one source. So in some of the work we did for Federal Highway Administration, we did kind of a validation of FTOP freight flows and its routing against something called the Commodity Flow Survey. So the Bureau of Transportation Statistics I want to say 5 years, does a sampling of freight providers and people who are in the freight sort of space to survey nationwide kind of the shipment level information of like where is this coming from, where is it going, what sort of mode does it use, and that gets built up and released as a public data product called the CFS. That then gets sort of connected into something called FAF, which is where we get our network from, the Freight Analysis Framework. And they have FAF zone to FAF zone flows at different commodity levels, different commodity types. And that's also available on their website. Recently, actually this year, and I think they announced it at TRB, they did a disaggregation of that FAF information to the county level. So that's, geospatially the most granular. I think that's publicly available. A lot of other, academics and other folks have previously had done disaggregations of the FAF flows into this county to county, but BTS released their own version of that earlier this year. So I think that's a great place to start. Ultimately, we also do end up thinking of other sources of data like TransSearch and other places where you can kind of make a data purchase and use it for your analysis. But that, that requires you to purchase a subscription or kind of a data set from them.
Yeah, that's super helpful, yeah. Any other question? Okay, great. Maybe we can conclude here. Thanks, Kevin, for a wonderful talk, and thanks, Kevin, and also the audience, everybody, for this wonderful conversation session. Thanks a lot.
Yeah, thanks for having me.
Yeah, thanks. We hope to one day be able to host you in person at Berkeley in another event.
Exactly.
Thanks a
Yeah,
lot.
that'd be great.
Bye-bye.